So the sieve of Eratosthenes is basically, we're looking at a way to find prime numbers. There are several very important Greek mathematicians. Let me mention a few more names. So the famous Greek mathematicians now are Euclid and Eratosthenes, Archimedes, Thales of Miletus. There's another guy who's in this ancient category named Ptolemy. So those are some of the people that were very influential in ancient math and ancient science. There's not too many but that we talk about, but they are there. The ancient Babylonians, the ancient Egyptians, the ancient, Indians, Chinese, Africans, everybody has something to say about counting in mathematics. And the Greeks gave us, Euclid especially, gave us a framework for understanding math that was very different from everyone else. I'll tell you something interesting about human beings, and then we're going to do the sieve of Eratosthenes, and then we'll take a break. But part of what happened is that before Euclid, and actually just since the beginning of time, it seems like human beings have always been fascinated by the universe, right? Especially when you look at the stars. It's just, it's like, where did this come from, right? And so there's this part of humans that is intrinsic. That like people long to know what the meaning of life is, or is there like, is there a God, or who are the gods? Those kinds of questions. That's the kind of mindset people had. Even during the time of Abraham in the Bible, there were a lot of people that believed in different, gods. And so the belief in God and in gods has been a part of humans for a long time. Now, there is only one true God, right? And the Bible talks about the creator of the heavens and the earth. God made the world, right? And God made the world, and we see the story through the scriptures. We see his revelation in nature. We see his what he did for us through the Jesus Christ. And so we know there's a story that we can talk about. We'll talk more about this, which is that, again, God created the world, and humans seem to be asking that question all the time. And so if you believe in the Bible, and if you're a Christian, you sometimes take it for granted the reality that you've come to terms with, which is the fact that the universe makes sense because God made it. Then we can study it. That's part of what's happening. And so one of the things that Euclid tried to do was try to make it so that people can study logic and mathematics away from this discussion of the gods, right? And of course the Greeks were not Christians because there was Jesus hadn't come yet, right? So they were not Christians. But they had a philosophical framework and that they operated under. So we'll talk more about the philosophical and theological side of this discussion. But right now, I just want you to know that what Euclid did was a big change, a big shift in math, in the world of math and science. There was another gentleman that came after him called Archimedes. Archimedes was also very exceptional. And we'll talk about Archimedes in a different lecture. But let's talk about the sieve of Eratosthenes. One of the most important types of numbers ever is a type of number called prime numbers. Prime numbers are important because they help us in cryptography. They help us in understanding how to work with fractions. And I'll show you an example of that before we leave today. We're going to do, we only have about 7 minutes, and I want to show you why, if you know prime numbers, you will actually do much better. And so let me quickly show you the sieve of Eratosthenes. If you write the number 1, 2, 3, 4, 5, 6, 7, 8, 9, like if I just wrote those numbers and 10, right? And then I came down and I wrote 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Let me go up to 30. 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. So the first thing we need to figure out is, what are prime numbers? What are the first set of prime numbers? So let's figure that out first. 1 is not a prime number, and it's not a composite number. A prime number is a number that can only be divided by itself and 1. 1 is not a prime number. A composite number is a number that has components. Think of it that way. It has factors that make up that number other than itself and 1. Okay, so for example, 4 is a composite number, so it's not a prime number. But let's go ahead and use the sieve of Eratosthenes to figure out the first set of prime numbers. So here is how you find prime numbers. You take the first number here, the number 2, and you ask yourself, can I divide 2 by anything apart from itself and 1? And the answer is no. You can't divide 2 by anything other than 2 and 1. Therefore, 2 is a prime number. So I'm going to circle the prime numbers, okay? So any number that I circle is prime. What that means then is that all the numbers that number multiplies to give us, so for example, 2 times 1 is 2, 2 is prime, 2 times 2 is 4, that means that 4 is not prime. See what we just did? We canceled 4 because 4 and 2 have a certain relationship such that 4 is a multiple of 2, or we can say 2 is a factor of 4. So it's important to be mindful of that term, factor and multiple. We'll talk about it when we get into the chapter on multiplication. But we have 2, that needs to stay prime. 4 needs to go away. That means 6, 8, 10. Do you see what's happening? I'm canceling all the numbers that 2 goes into. And I'm going to do the same thing. 12, 14, 16, 18, 20. And then 22, 24, 26, 28, 30. So all the factors of 2 are gone. All the multiples of 2 are gone. Because 2, again, that's a prime number. All the others are not prime. Okay, now we go to 3. We ask, can you divide 3 by anything apart from 3 in itself? And the answer is no. So therefore 3 is prime. So notice that I've circled the prime numbers 2 and 3. The next one, that means that if I circle 3, I have to cancel everything that is a multiple of 3. So if 2 is prime and 3 is prime, all the multiples of 3 have to be canceled, meaning that 6 is going to be canceled, 9 is going to be canceled because it's a multiple of 3, meaning that it's a composite number and it is not prime. The goal of this exercise is to find the prime numbers. And then we go over here, 12 needs to go. So it seems like in order to do the sieve of Eratosthenes, you need to know your multiplication facts, right? Your 2 times table, 3 times table. You want to know your times table all to 12, up to 12. And I have a book called Tools for Mastering Math, which I'll send to you guys. You guys can use that as a way to have a reference for your multiplication facts, addition facts, all the different rules you need for algebra and stuff. I'll send that to you. Okay, so 2 goes away. 2 and 3 are prime. So all the multiples of 3 need to go away. So 12 goes away, 15 goes away, 18 goes away, 21 goes away, 24, 27. So I've canceled, and 30. I've canceled all the multiples of 3. So that means 2 is a prime number and 3 is a prime number. Now we move on to the next number that we haven't canceled yet, and that's 5. So then we ask, is 5 a prime number? Is there any number that can go into 5 without any remainders? And the answer is 5 is actually a prime number because nothing goes into 5 except 5 and 1. So we write down 5 over here. We circle 5. And guess what? We cancel all the numbers that have that are multiples of 5. So that's 5, 10, 15, 20, 25, and 30. So we've canceled all the numbers that are multiples of 5. Now we move on and say, what's the next number? 7. Okay, is 7 a prime number? Well, 7 is the only number that can go into 7 and 1. So we circle and we say, yes, 7 is prime. And then we go and cancel everything that is a multiple of 7. So for example, 7, 14, 21, 28, and those are already canceled from the other ones. So that means, again, 7 is a prime number. The next number in line, we look at 8, 9, 10. Those were canceled. They're not prime. They're composite. So we go to 11. Is 11 a prime number? That means that is 11 only divisible by itself and 1? And the answer is yes. And so we circle 11 and we add it to our list. 11 is a prime number. So then we cancel the multiples of 11. It'll be 11, 22, which is already canceled, 33, 44, 55, 66. Those are the multiples of 11. We keep moving in line. We get to 13. 13 is a prime number. Okay, so 13 is a prime number. So now we cancel all the multiples of 13. So we do 13, 26, 39, and so on and so forth. Okay. Then we move on, 14, 15, 16, 17. 17 is a prime number because it's only divisible by itself and 1. So we write it down, 17. 19 is a prime number because it's only divisible by itself and 1. 19. 20, 21, 22, 23 is a prime number because it's only divisible by itself and 1. We keep going. We have 24, 25, 26, 27, 28. 29 is a prime number because it's only divisible by itself. And 1. The first 10 prime numbers. This is actually going to be a fun math problem. Imagine if somebody came to you and said, find the sum of the first 10 prime numbers. That's actually a very beautiful math problem. I think we should make that a problem, like a competition. What is the sum of the first 10 prime numbers, right? So maybe that will be our test question next week. What's the sum of the first 10 prime numbers? So then if you forget what the first 10 prime numbers are, you can derive them and then you can add them, right? That's the way I would approach this problem. So this is called the sieve of Eratosthenes. We can use it to find prime numbers. So imagine if you went home and you wrote the number 1 to 100 and you actually found all the prime numbers that are less than 100. That would be a very good exercise to show that you understand the sieve of Eratosthenes. So let's recap as we land our plane. Some of the books that we're going to be using in this course are over here. I already showed you the one about Isaac Newton. It's called, we're going from counting to calculus, so it makes sense to know who Newton is. This is a book by about Leonard Euler. He's the other greatest mathematician the world has ever seen. We're going to talk about the founders of electricity, or the people that gave us the math and the science about electricity, Michael Faraday and James Clerk Maxwell. And then this is the last book here called Journey Through Genius. Journey Through Genius is a book that I wish everybody would read in their math classes. And it talks about the history of math from the ancient times to the present. So these are some of the books we're going to integrate into our discussion. You don't have to read them. I'll be reading them and I'll be sharing them with you. And we're looking at math in a think of it like a timeline where we're starting from the days of Abraham and we're working our way all the way to 2024. 2024, right? So we're going to learn math from basic math all the way to calculus and beyond for fun. I'll send you all a video to watch that will show you how to use prime numbers. But one example, just because I did say I'll just give you one example, is if somebody tells you what is 12 divided by 18, what you can do with 12 divided by 18 is you can prime factorize 12 and you can prime factorize 18 using a factor tree or a factor ladder. And when you prime factorize 12, you get 2 times 2 times 3. So I'm going to write it down here. You get 2 times 2 times 3. You know that a dot usually means multiplication. So 12 is 2 times 2 times 3. 18 is 2 times 3 times 3. You can cancel what they have in common. You can cancel the 2's, you can cancel the 3's. So the answer of 12 over 18 is 2 over 3. I was able to do that because I know what the prime numbers are that make up 12 and 18. We are going to talk more about this. I'll tell you a secret as you go. Did you know that if you know how to work with prime numbers, pre-algebra will be the easiest math class for you because prime numbers are the foundation of pre-algebra. So if you know prime numbers, you will be the best in math in pre-algebra, or at least one of the best, because fractions will be easy for you. Adding them, subtracting them, multiplying them, dividing them, no problem at all. And so next week, I'll give you all the secrets of how to use prime numbers, multiplication and division to become exceptional in pre-algebra. If you're already done with pre-algebra, then just come ready to learn how to teach other people what I'm going to teach you next week. Okay? So I'm going to stop and then we're going to say goodbye.